All right, folks, hopefully you were able to practice with the intercepts, finding them and using them to graph a line. Now we're going to talk about slope. I mean, when you think about a line and important features of a line, there are things like, where does it cross an axis? But then another probably more obvious feature is what is its steepness, right? And how do you actually quantify that? Well, I will show you. So we want to turn to slope now. And at its very most basic notion of slope is that it's just a numerical measure of the steepness of a line. Now, what do we mean by steepness? Well, steepness is really a ratio, right? And that it's a ratio of how far up do you go over some horizontal distance. And that's what we mean by rise over run, okay? How much elevation do you gain or lose over some horizontal distance? And so let's look at this graph here. I've got a couple points, and I'm gonna label them. Now, this point here, I'm gonna call x1, y1. Now, I'm using subscripts because I've got 2 points and each point has an X and a Y, right? So to distinguish them, I need to call the first point X2, Y, I'm gonna call the first point X1, Y1, and the second point X2, Y2, all right? So those are just arbitrary coordinates. Now let's look at this. Here's X1, right? Here's the value of X1. And here is the value of y1, right? If I were plotting this point, I'd go right to x1 and I'd go up y1, and there would be my point. Similarly, right about here would be my x2, and right about here would be my y2. Now you can see that if I don't have to be moving left to right, but let's just say we are. If I'm moving left to right, then starting at x1, y1, I gained this distance over that distance. And that's what we mean by rise over run, okay? Rise and run. Well, how would you actually find this distance, right? From there down to there. Well, that distance is just the difference, right? If I start at 100 feet and I end at 150 feet, I've gained how much? Well, 50 feet. You subtract, right? So this distance here is y2 minus y1. Similarly, the run, right? I end at x2, I start at x1. So if I start, I don't know, 11 feet from the origin and I end 13 feet from the origin, I've gone 2 feet, right? I find the difference. So this distance is x2 minus x1. And so slope is going to be given by the formula y2 minus y1 over x2 minus x1. And this is essentially a change in y over a change in x, or rise over run. Now, we're going to use m for slope. Okay, now you should recognize m. You should have seen it before in our linear equations that we looked at, or our linear functions. And so that means my slope equation is really m equals y2 minus y1 over x2 minus x1. Okay, so there's the formula. All right, so let's try a couple. So here, this first one, I've got a line, and I've got lots of points. Notice there are units here, right? This has some context to it. So let's pick a couple points. I'm going to pick, say, this point and this point. And so this point here is 690, and this point down here is 230. And so the slope is gonna be, well, y2 minus y1, 90 minus 30, over x2 minus x1, 6 minus 2. And then we just reduce this. So 60 over 4, which is going to be what? 15 over 1. But remember, we have units here, right? This is calories per minute. And so the slope is 15 calories per 1 minute. Okay? How about this one? Well, how about we pick, ooh, I like this point right here. And then how about this point down here? 5, negative 6. So the slope will be negative 6 minus 0 over 5 minus 1. So we have negative 6 over 4, or we could call that negative 3/2. Now, you might be wondering, I see other points on this line. What's so special about the two you picked? Well, nothing. Let's try this again. Let's say that you picked this point, and I don't know, how about this point right here? Well, this point down here is 3, negative 3. Right? If they're on the same line, the slope should be the same, right? It doesn't matter where you move on a line, you're experiencing the same steepness. So we should expect that our arithmetic will work out to give us, well, negative 3/2. So let's see if it does. So if I'm using my red points, let's see, negative 3 minus 3. And then my run, 3 minus negative 1. Well, a negative 3 minus 3 is negative 6, and 3 minus negative 1 is positive 4. Hey, what do you know? You get negative 3/2 again, okay? Notice there's no context here, there's no units involved, so I'm leaving this completely just, right, there's no units to assign, so this is just the simple ratio. All right. So let's do this again with just a couple points, right? So, excuse me. Find the slope of the line passing through the given points. Well, I'm going to use this second point as my y2 and x2. So negative 3 minus 2 over 2 minus negative 4. So what is that going to be? A negative 5 over, and then 2 minus a negative 4 is 2 plus 4, so 6. So I get negative 5/6. Well, that's the correct answer. I want you to notice something. What if we had done this the other way? What if instead I had used that point, then that point? So in other words, instead of doing negative 3 minus 2, what if I did 2 minus negative 3? And what if then I did negative 4 minus 2? Well, look what happens. 2 minus negative 3, that's 2 plus 3, and negative 4 minus 2, negative 6. And so you get, again, negative 5/6, the same slope. But what's going on here graphically? Let's think about this. So if I had some points, like let's say I had the point, you know what I'm going to do? I'm going to steal a graph from up there. That'll be easier. Let me go get a graph. I'll be right back. Okay, so I got this graph here. And let's look at what's going on. So my first point, negative 4, 2. 1, 2, 3, 4, 1, 2. And my second point is 2, -3. So down here. Now, you can connect the, whoa, what a horrible line. Let me try that again. Actually, maybe insert a line. Let's do that. So from here to there. Okay. Now let's think about this for a second. In the first case, I started with 2, -3. So that was this point here. If I'm at 2, -3, and I want to get to -4, 2, then that is like going, oops, so we need red here. I'm using red. I want to use my red. Give me my red pen. Oh well. So this is like going up a distance of 5, and then going left a distance of 6. Well, up is a positive direction, and left is a negative direction. Notice where the negative is in this second expression for slope, right? It's in my denominator. My run was negative. So in this second expression, this was like going up and then left. But on the other hand, what if I started here and wanted to go down to 2, -3? Right? What if I was starting at -4, 2? Well, in this case, I would go down 6 and then right 5. Well, how would you describe it if you're going, I'm sorry, not 6, 5. Going down 5 and right 6. So if you're going down 5, down is what direction? Oh, it's negative. And what do you notice here? Negative, and then 6 is positive. So this first slope we found was like going down and right. But notice, down and right, up and left, right, you're still sitting on the same line, which is why the slopes are the same. So does it really matter which point you choose as your x2, y2 versus x1, y1? No, it doesn't. Just be consistent. If I'm going to choose this point as my x2, y2, then I need to make sure that -3 and 2 are coming first in my differences, in numerator and denominator. Okay? All right. How about this one? Well, how about 1/2 minus 1/2 over, and who cares if they're fractions, right? We're still subtracting. -5 minus -2. Well, 1/2 minus 1/2 is 0. -5 minus -2 is -3. So this slope is 0. There is no rise. Okay? You think of this as a horizontal line. Okay? In fact, if you plot these points, and I would encourage you to do it and verify, the only line that you could connect them with would be horizontal. Okay, so how do we actually use this to graph? Well, here we have the slope-intercept form, right? And when an equation is in this form, then I simply look and I can see what the slope and the y-intercept are, okay? So here's our steps. Identify M, identify the y-intercept, plot the y-intercept, and then make sure that you use the slope from the y-intercept, right? The slope, think of it as a rule of how to get from one point on a line to another point on a line. Let me show you what I mean. So we're going to do a few of these here. So I'm going to bring these together here. Come on. There's one. All right, let's try this again. Okay, just come back to this. So my first line, my y-intercept is 0, 6. So 0, 1, 2, 3, 4, 5, 6. Okay. My slope is negative 4/5. Well, I can put this negative anywhere I want. I can put it in the denominator, or I can put it in the numerator. The reason is positive divided by negative is a negative. Negative divided by positive is a negative. This is like going up and left or down and right. It doesn't matter. So what I'm going to do, just because of the constraints of the graph, right? If I went up 4, I'd run out of room. So I'm going to go down 4. 1, 2, 3, 4. So that's my negative direction, right? I'm going to go negative over positive. And then I'm going to go right, 1, 2, 3, 4, 5, okay? And there's my line, okay? I went down 4, I went right 5. Okay. All right, let me grab another graph here and we'll do the next one. All right, so this other one, B, this will be B here. I have a slope of 3 and a y-intercept of 0, 4. So 1, 2, 3, 4. There's my y-intercept. And then my slope is 3. But remember, slope is rise over run. I need to know how far to go up, how far to go over. So, well, I should say how far to go up or down, and then how far to move left or right. So let's take 3 and just write it as a fraction, okay? And so notice that this is positive over positive. Could also go negative over negative. Either way works. So my rise is 3. So I'm going to go up 3. 1, 2, 3. Maybe I'll write that. Rise is 3. And my run is 1. So up 3. 1, 2, 3. And right 1. Just for kicks, notice I also could have gone down and left. Down 3. 1, 2, 3. And left 1. Right? Same line. Do you have to do both of those? No, that's not the point. I just want you to notice, observe that. Okay? All right, and the last one, a slope of 0. Whoops, come back. A slope of 0 and a y-intercept of 0, negative 5. Okay, so for C, my slope is 0. And my y-intercept is 0, negative 5. All right, so 0, negative 5. 1, 2, 3, 4, 5. And then with a slope of 0, there is no rise, okay? If I want, I could write the slope as 0 over 1. Shoot, I could write it as 0 over 7 if I wanted. But there's no up or down. There's only left or right. So if I write 0 as 0 over 1, then I'm not going to move up or down at all. So I'm going to go up 0, I'm going to go right 1. Okay? Notice that this is a horizontal line. Okay? In fact, all lines that are horizontal have a slope of 0. All right. So now, let's put this into take this a step further. Notice that we have a couple equations here, okay? And we want to graph these. So for A, we have negative 2/3 x minus 3. So my y-intercept is 0, negative 3, right? That's that B in the form y equals mx plus b. So 0, negative 3, down 3. There's my y-intercept. My slope is negative 2/3. Now you decide where to put the negative. Again, we could go up and left, or we could go down and right. I'm going to put it in my numerator. Why not? So if I do it this way, this is negative over positive. If I had done it the other way, 2 over negative 3, that would have been positive over negative. Okay? So another way of thinking about this is down and right, or up and left. So if I go down 2, 1, 2, and right 3, there's my other point. Okay. And voila. Okay. All right, so let's do the last one. And I would encourage you to pause it and try the last one on your own before you watch me do it, because you should notice that the last one has an issue, right? I can't just look at this last one at B and say, oh, the y-intercept is this and the slope is that, because it is not in slope intercept form. Okay, it's not in the right form, but you can put it in the right form. So take a moment and do that. Pause it, try it, and then come back and we'll do it together. Okay, so I need to solve this for y before I can just look and say what the slope and the y-intercept are. So I subtract x from both sides. I divide everything by 5. Now remember, this is really a negative 1x, right? So I can write this as, well, 20 over 5 is 4, minus, and I'm going to write 1/5 x. If you want, we can turn this around. And voila. B is 4. So I come over here, 0, 1, 2, 3, 4. And then my slope is negative 1/5. Again, we got this negative. Where do you want to put it? Oh, why not? Let's put it in the numerator. I'm going to go down 1, right? That means my rise is negative 1, and my run is 5. So down 1 and right 5. 1, 2, 3, 4, 5. And there's my line, okay? So you can see why we've done some practice, like in our last lab, trying to solve for y. The goal is to get it in that function form, y equals mx plus b, because once we have that form, we're good. We can just look and see what the slope and the y-intercept are, and then we're able to graph, okay? Now, right now, this is all very mechanical, not a lot of context. You want to get this down, because when we come back, we're going to start applying this. We're going to look at some linear models. So, quote, real life situations that can be described mathematically using a linear function, okay? So work some problems, get really used to graphing and manipulating equations, and I will see you soon. Bye all.